This is called Axminster, and it is a software design modeling tool using UML, and which is the Unified Modeling Language, and OCL, the Object Constraint Language. If you watched my earlier video where I said, right, I've built a 1990s Java dev shop out of AI agents, I had used a collection of sub-agent definitions to build an agent that works with each of the different types of UML diagram, but using the plant UML format. And that had the difficulty that the models weren't constrained to generate valid diagrams. They would create things that weren't in correct plant UML syntax, or that weren't in correct like semantic UML, and that meant that like it was hard to sort of use those diagrams as part of a design process. And this app effectively constrains both the human designer and the AI agent to only use like semantically valid constructs. So I can't just like draw shapes on the canvas. I have to create a system boundary, and let's model my digital nature journal app that I've been working on, which is called On the Wing. So the actor in that is called an observer, because they are out in nature. They're like recording what they see and reviewing it and adding it to their journal. That sentence already gives us a set of the use cases. So the observer can capture an observation. They can record observations in a journal, and they can review their journal. And it's the observer actor who does each of these. So we'll create an association between the observer actor and each of these use cases. So it's a bit like the UI forces you to do the things that make for valid UML constructs. You can create other types of diagrams. So I could create sequence diagrams, state machines, activities, components. The other part of this app is, of course, I can go through these things, and I can also inspect the different things. I can add OCL constraints to like the various nodes in the design. So can an AI agent. While the app is running, it's also running an MCP server. So I'm going to save this model. It saves in the XMI format. That's the extensible model interchange format, which is the standard defined by the object management group, who also maintain the UML and the OCL standards. So it's an XML format that other modeling tools should be able to load. When the app's running, it also runs an MCP server so that a coding assistant can connect to the models and can use those to guide development. In addition to reviewing the model and finding out what my intention is for the project, the coding assistant can also make changes to the model to ensure that the model is in sync. And unlike using markdown specification files as a traditional spec-driven development workflow would do, these are of course graphical models, so we get to see a visual representation of the software, making it easier for the developer to understand. Of course, the MCP server provides tools that only allow for semantically valid modifications to the model in the same way that the UI does. So the human and the LLM working together are making semantically valid transformations to the model. In other words, you can only use this to make consistent models, and the LLM can only make consistent changes. In the Chiron Codex world, this is the replace vibes with tools pattern. What we're doing is ensuring that the model only has deterministic ways to effect changes to the model. So let me start a coding system. We'll use anti-gravity for the demo. See what MCP servers it has. Good, it has access to the Axminster server. I'll tell it about the on-the-wing model. And let's first just see that the LLM is able to review the contents of the model. Okay, so now the LLM should generate tool calls to use the Axminster MCP server to find the model and to read the elements in the model so it can find the associations we asked for. Okay, and those are the three entries that we see in the model. The LLM can also make changes to the model. So let's try that out. Let's see if the model is complete and get the LLM to update the model with any changes. So I'm just going to get it to effectively do a round trip and to bring the representation of the model in line with the capabilities of the software as they exist in the software source code. You can see that the representation of the model in the app is kept in sync with the changes that the MCP server makes. So I get to see in real time the changes to the model of the software that the MCP server is making, that the LLM is making through the MCP server. And it's identified that all of the existing use cases were implemented and that there are three others: reviewing observations, viewing the entry, a single journal entry, and managing the observer's profile. And it's used the MCP server to add that. So there we go. We have a visual model of software that is in a semantically valid form, and that a human developer and an LLM coding assistant are able to collaborate on, and each can view the current state of the model with the modifications that both of those actors are making in a consistent way. So that's Axminster. It will be available on TestFlight soon and on the App Store after further development and feedback from beta testers on TestFlight.